withdrawal symptoms and refuse to go. Did you hear all the kids in the town accompanied by the rats are coming to rescue us now from psychiatric clinic. High off the ground, can't catch us now. Can't make a sound, I guess we're good at escaping. High off the ground, can't catch us now. Can't make a sound, I guess we're
Sure. Hello, everyone. Hello, everyone. Good evening. Okay, that's very nice.
Okay, we'll give it test. Everyone can hear me? Okay. Tomasz, we'll give it like 2 to 3 minutes so that more people can arrive.
2 3 minutes. Okay,
Yep.
fine. Sure, thank you.
It's Balkan Bonton that you need to be late at least 5 minutes for each meeting. So
Sure, no problem.
So that's
no
why
problem at all.
We'll wait for a bit.
Sure.
Christmas, there is just one thing I need.
Okay, let's start. So guys, thank you for joining this edition of our Angular Macedonia meetup. This meetup is significant for us because it marks a milestone. And last year, around this time, but 2 months before this time, we started this meetup community, which is built for everyone that's interested in Angular, learning Angular, and learning front-end development to join us and to keep us company at this trip to improving ourselves to be better front-end engineers, better developers, and better persons. So today we have two amazing speakers. The first one is Tomasz. He will be speaking about Angular and state mechanisms, and he'll say more about the subject. So Tomasz, welcome. Glad to have you. Go ahead.
Hello, everyone, and thank you for letting me speak to you. Hello, Angular Macedonia. So, we're gonna speak about Angular Query. This is well, actually, not only Angular Query, but actually all the, let's say, issues and tasks related to managing the server state in our client applications. So this is important for pretty much all the applications that we write, because first we need to fetch some data from the server so that we can actually, display them, allow the user to manipulate them, process them, etc., etc. So data fetching and managing the data fetched from the server is one of the kind of fundamental tasks. And what Angular Query brings us, compared to everything that you could have seen before, is that it is really good at doing one exact thing, and it does it very well. So my name is Tomasz, and I've been working in the industry since 2007, something like this. And I started in languages such as Java, PHP. I did some Python for a few years. I think I also did some C++ and Perl, but other than that, in 2012 or something like that, I moved to JavaScript, and since then I have been focusing mostly on JavaScript, TypeScript, Angular, React, architecture, design patterns, performance, testing, and so on and so forth. So pretty much everything around JavaScript. And right now I'm an independent consultant. If you feel like you have any obstacles in your projects and you need some help, I can help you. I can kind of assist you. I also do trainings on the features mentioned. So why do we even bother about Angular Query and specifically about state management? So let's start by kind of differentiating the state into two major groups. One is the client state, and the other one is the server state. So of course we could, divide server in many different categories. Let's simplify it that the server state is essentially whatever is being held on the server side, like in the database, whether it's SQL, NoSQL, whatever. So whatever our client application needs to fetch in order to process it further, in order to allow it for the user to interact with. And the client state is whatever the user has done with the data. For instance, let's say that we fetch a collection of some items, some data, and after this, we allow the user to display a form that would allow us to modify the data. So the thing that has been originally fetched from the server is the server state, and the client state is, for instance, all the manipulations. So where Angular Query shines is server state. So Angular Query is not at all interested in any way with client state. So what is important here is that if you, let's say, think about NGRX, the classical one based on observable streams, or if you think about RxJS signal store, so NGRX signal store, of course, then you could think that all of these solutions are actually kind of universal. They could be used for both the server state and the client state. And on one hand, it's nice that you can pretty much have everything within one library. But on the other hand, try to think about it that if we have a saying in Poland, if something is meant to solve all the problems, it doesn't solve any problem well. If something is for everything, then it's for nothing. If something tries to be too universal, then it cannot, address a very specific problem very, very well, because it cannot walk into any of the abstractions, because by walking into one abstraction, it would not fit at all any of the other abstractions. So what Angular query is trying to do, or actually not only Angular query, but TanStack query, React query, Angular query, Vue query, Solid query, etc. This is basically the same library, just different ports for different frameworks. So what it's trying to do is to do the server state management, but to do it very, very well. So why bother? Well, we need to fetch the server state, first of all. Probably we would like to have some declarative API. By declarative API, I mean that we would like to declare some dependencies that, let's say, one component would like to depend on a external endpoint, some external data resource. And whenever, let's say, a new component pops up, it would reuse the data. If no components are using a certain endpoint anymore, then there would be no data reload, etc. So basically, we don't want to handle this imperatively because we would be responsible for pretty much all the edge cases, all the use cases, all nitty-gritty, low-level details. So declarative API would be very useful, especially if we Angular developers are used to working with RxJS, which is highly declarative. Like doing RxJS imperatively would not be a very good fit. We need to think about caching and sharing. So sometimes we would like some data to be reused across some components, some modules, some views within our applications. Sometimes we would like them to be cached, but on the other hand, we might want to have some data being reloaded every time, or we would like some cached data to be invalidated after some time. So like pretty much we need to deal with these all the time. Cache invalidation, like in HTTP, whenever we fetch some data, pessimistically, we might need to, of course, not always, but quite often, we might need to consider that the data that we have fetched and displayed could be already out of date. So, for instance, if I fetch my, let's say, payments from a bank account, or if I fetch, I know, currency exchange, then every second, it could be different, right? On the other hand, there could be different, let's say, a list of countries available worldwide. So like, 200 something of the countries. So this doesn't change very often. So, we have different endpoint, different types of data, and their frequency of changes is also different. So again, if we could basically configure it at a high level, that would be useful. Yet again, we should pay attention to error handling, possibly to do retries. Now, this is easy with RxJS, though still it would be nice that we wouldn't have to care about this every single time for every single use case. So why not preparing a configuration once and for all? Finally, if we load some data that we want to display on one component, let's say, and then there is another component that would like to use the same data, what is the sweet spot between sharing the data or between the reloading? Maybe we would like to preload, prefetch the data. How often do we refetch? How often do we want to reset the data? And so on and so forth. And finally, eventually, automatic garbage collection, pagination, data loading, a state machine for data loading, infinite queries, and many, many other related topics. So if I said that Angular query, or the whole family of TanStack query libraries, is good at something, then this is certainly this, like everything that is related to data loading. Now, if you think about it from your from perspective of whatever you're using, if you wanted to provide the fetching itself, along with refetching, prefetching, caching, sharing, invalidating, error handling, etc., 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 or providing state machines, like I'm pretty sure that you would provide only some of them because you might just not care about some of these features, unless a problem happens, or unless there is a bug for the user, or unless your business finds out that something is just not performant enough, right? So that's the whole point, that by using this library, we get them for free. So I would say that there is Angular query follows the Pareto principle in a way that roughly Pareto principle says that roughly 80% of consequences come from 20% of causes. And in a way that Angular query follows this is that we would say that 80% of the features and use cases that you might need is being implemented by 20% of the API. So in other words, in order to start with Angular query, you need to know very, very little code. So after this presentation, you'd be good to basically take the library and code with it. Actually, there are going to be just 3 lines of code that would be important only. So yeah, and if you need to opt out from the default behavior, which is, let's say, only 20% of the use cases when you need to opt out from the defaults, then yeah, this has really, really, really lots of various flags, various strategies, options, and so on and so forth. So this is really powerful, but still, the most common use cases are being covered by the defaults, so that in most cases, we would be just using 3 lines of code. So 80% of features come from 20% of the API. Sounds like a good sales pitch. So let's proceed to the code. So what is what are these 3 lines? So we have a class that represents a component or a service or whatever. And what we do here is that we create a query, whether this is a public, private, protected property, never mind. So what we do on line 4 is we inject a query. So as the name suggests, Angular query, Tanstack query, etc. A query is the, let's say, core element, core building block of the system. So think of a query as a dependency. So my component or my service or whatever depends on a query, like query when you query a database or when you query an API. And the query here, defined by query key, which is a product, whatever, this basically means that whether this is a component or a service, it requires the data of these products to be available in order to display them, process them, do something with them, whatever it is. And what we've got here is the query function in, inject query in line 4, the query key, which identifies the query itself. So basically, like the internals need to figure out which query is which. So think of the query key as an identifier, identifier-ish, something like an identifier. And finally, the query function is whatever Angular service you have there with whatever RxJS-based API you've got there. Basically, take whatever you've got in your project, as long as it returns observables. If it returns promises, it's also okay, but this is perfectly fine with observables. So and inject for the product HTTP service or whatever is your certainly the thing that provides you the HTTP method. So yeah, that's it. How we can use this one is that the query is going to handle all the, let's say, states that we need to take into account. And these are that we are initially loading, or we are reloading, we are preloading, etc., etc., etc. Or we can basically grab them into a group of loading. Or we could have the data successfully loaded. And here we've got the 4p of query data, and then track p.id, whatever we want to do here. Still, whenever the state of the query changes, the component will be notified in order to update itself, right? Because there is a new data available through signals, of course. Query.data with the call, with the invocation, this is a signal. So what the Angular query adapter for Angular is doing is taking the original, the query core library, and wrapping it whatever is convenient for Angular developers. In our case, these are signals. So as you can see, this is already kind of future-proof, that it's aligned very well with the future that we are expecting in Angular. So all in all, initially, we would need to first do an if statement, which I just dropped here just for simplicity. But we would need to do an if statement to check whether we are in a loading state, or maybe we did have some error. And if none of these 3, then maybe we just have some data available. So all in all, there is a built-in state machine. Though still, I have only 25 minutes, so I cannot fit everything into a single presentation. Though, yeah, that's what we do. Again, if we take a look here, essentially, line number 6, query function, is something that you would do somewhere anyway, like calling the RxJS function. right? The RxJS method, whatever we call it, right? So we would need to have it. So the only additional things is that there is a line with the inject query, and there is a line with the query key. And apart from that, this is essentially what you would have. For instance, from the toSignal call, the interop between the signals and observables, or if you've been using the recent resource that was introduced very recently in Angular, this would be very, very similar. By the way, you can also think about Angular query as something that is 100 times more robust than resource. Resource is a magnificent API. And actually, what does it mean, resource? You want to fetch some resource from the outside. And this is essentially what Angular query does. But Angular query allows us to, have tons more features that resource is not yet, at least not yet, interested in. So yeah, anyway, the thing is, if there is at least one component that is interested, or at least one consumer, because it doesn't have to be a component, it could also be a service. If there is at least one consumer that is interested in the data, there is an underlying mechanism that is going to see whether we do already have the data, whether this data is still up to date, or maybe it's stale, so that we need to reload the data while displaying the cached version, etc. This all happens automatically. And this is amazing. Like, this is all you need to write. And you're good to go. And there is, as I said, tons of other things that we are going to take a look into. So let's say that we need to introduce some pagination. So let's say that some interesting things will start to happen. We could have, pagination, sorting, filtering, something that would depend on your entity ID, really, whatever. And yeah, we create a page that is going to be an input, a signal, really, whatever. And we have a method next page that here is a this.page.update, and for v, whatever is v, we return v+1. So essentially, we're just going to increment the page number. So how does this affect our setup? So all in all, what is kind of a source of quite a lot of design issues or even bugs when people try to figure out these things manually is that, let's say, you only hold one array for the data that you currently display, because you need to only have one array, one object that holds, let's say, the first page. Now, if you wanted to increment the page, let's say from page 1 to page 2, you'd basically replace the old one with the new one, right? Because somebody would say, hey, I don't need to hold the old data, because that's the reason the user moved to the next page in the first place, that the user didn't want to look at the first page, right? But the thing is, what if the user clicks previous or go back? You don't cache it, unless you would have to provide it explicitly. But here, you don't have to care, because products page 1 and products page 2, just as you can see over here, there is just, apart from the products, there is this curly braces, the object literal with the page key and value 1, value 2, value 3. These are, as a whole, they are different keys. So they are going to be cached separately, right? And that's the thing. If your user walks to page 1, then goes to page 2 and goes back to page 1, then why refetching the data? You could use a cache. Of course, you don't have to, but you can use it by default. Going to the data after 1 second, it's not very highly probable, or I don't know, after 30 seconds. It's not highly probable that the data would change by that time, but even if you wanted, there are solutions to do that. All in all, what happens here is that the query function might not be, hard-coded at this time, so it would be parameterized. So all in all, we would need to know what is the query key, and hence here we can figure out that the second parameter of the tuple, the criteria, could be essentially, an object including the page, the sorting, the filtering stuff, whatever. And we just simply pass this criteria object to whatever is your method on the HTTP service. Fine, right? And again, you would be reusing your underlying service anyway. And if you take a look at the most important line here, the query key line, is that you do organize the data that you fetch, that you retrieve. And the thing is, you don't need to have, one variable that would be basically, kind of replaced by different data with different search keys, etc. Like first, you don't have to care about that. And again, this is not a server-side solution. So here we have all the RAM of the client that we can use. But also, if the data is old enough, then it's not going to remain in random access memory, RAM, forever. This is going to be deleted by the time that you define, and the default is, I guess, something around few minutes, but you can change it. It's basically a yet another flag in inject query, and that is cache time, or GC time, sorry, GC time. For after how long to delete, I think, right? So yeah, we could have dynamic keys and use methods with dynamic parameters underneath. And as you can see, this perfectly aligns with signals and all the features that we have in signals. So what is the big picture? We have seen queries already. We have seen keys, and we will meet mutations. So we can see like what is going on in a big picture. So at the very bottom of the picture, we have a hierarchy of components within our application. So all these, wide rectangles represent a single component. So there is this green thing over, so this green thing over here is a query client. So a query client is the, let's say, the object that we interact with directly in Angular query. So there are more things underneath, but actually when we're doing inject query, the query client is what we deal with. So here you can see that the components are throwing this dashed arrow, the green one, into the query client. So here they basically kind of express that, hey, dude, I depend on products, or products page 1, or products page 2, whatever. So what happens then? Query client basically checks whether the data is already in the cache. If it's not in the cache, then query client thinks that, okay, so since the data is not there, then I'm going to fire a request to the real API using the query function. So using your, HTTP service, RxJS function, whatever. When the data is being retrieved into the query client, then query client puts it into the query cache, which is storing the data like as a big JavaScript map, where the key is essentially the query key and the value is the value retrieved from the server. Now, if any, and the data is being injected back into the components. Now, what is cool here? Let's say that the first entry is basically being handed over for the two components. So what is important here is that whenever there is a situation that there has been one consumer for a certain set of data and another consumer kicks in, then there is a question for query client whether this data is fresh enough. So if it's fresh enough, meaning it didn't outdate for any reason, then we can just reuse the data happily without doing any requests. If the data is considered to be stale, and by default, it's always considered stale, although you can modify it using a single property, which is stale time, in milliseconds, of course, then what Angular query is going to do is to it implements the paradigm called, or approach called, stale while revalidate. Stale, like I'm going to give you the stale data, while, which means in the background, revalidate, I'm going to re-render the thing. So if there is something that consumes a stale data or starts consuming the stale data, then I will give you the old one, but I'm going to reload it in the background so that, first of all, the user can see some relevant data, but on the other hand, we don't want the user to focus on the outdated data. So yeah, we're going to refetch it. Everything happens automatically, and what you want to do is actually to use the parameters to dynamize it. Yeah. So a perfect match that I would like to kind of convince you to give Angular query a try is combining it with NGRX signal store. So in this case, what is important is that, yeah, Angular query doesn't care about client state, and NGRX Signal Store is a solution that perfectly fits caring about the client state. So if you think about it, that Angular query is going to be the provider of the data that originates in the backend, and NGRX Signal Store is going to like supply the application with the client state, they like fit together very, very well. So our UI is going to, let's say, change so local state. What happens then is that this local state change is affecting the query key, for instance. Now, Angular query could do like, you know, some reloading, refetching, etc. It's going to fetch the data from the external API. Finally, both Angular query is going to feed the template with the server state, and NGRX Signal Store is going to feed the template with the local state. So they complement each other like really, really, really well. Because one is specialized in one thing, and NGRX Signal Store allows us to put the inject function, like, you know, not the constructor injection in old Angular, but the inject function in new Angular, in the with computed call, in the with methods call, etc. So, what we do in NGRX Signal Store definition is we just inject a query, and the with method or with computed in NGRX Signal Store has access to all the things like the state, the computeds, or the methods that have been defined in the store previously. So we can use the local state, and we can make the query, the injected query, depend on this local state. Like local, I mean from NGRX Signal Store. So they really kind of complement each other very, very well. So yeah, what's the point of the third thing, which is the mutations? So quite a bit of code here. So let's break it down. So at the top, we can see that there is a line number 1, HTML, button, click, and here is a mutation, mutate, remove. So essentially, we are going to click a button to run the mutation. Now we have a, yet again, component or service, whatever, we create a mutation. So instead of the inject query, we've got an inject mutation. So what happens here is there is a mutation function. So again, instead of a, let's say, query function, there is a mutation function. You can think of a way as read operations versus write operations. So a mutation is from CRUD, is the create, update, delete, whatever. Like we change something, whether it's adding, deleting, modifying, never mind. It's not just, you know, pure reading. It's just modifying. So here we've got products http.delete of ID, like changing something on the server, and accepting, of course, the ID as a parameter. Now we have an onSuccess callback, which accepts the result from the API, but it also accepts the parameter which started the mutation. So there are multiple different strategies which we could use here, but one of them is that, let's say, if we really want to delete a product in our product list, whatever that is, then we might want to invalidate queries. And here we've got the products lists key, which means that we're going to invalidate, which means mark them as stale. So whenever anybody needs them, they're going to refetch, which is this stay while revalidate. So show the user the old data, but immediately refetch in the background. And of course, then update the view, like through Signal APIs. So invalidating means like reload the lists. But if you manage to load the details of a certain product, of a certain ID, then basically the product doesn't exist anymore. So it doesn't make sense to reload it. So we could remove the query entries, the cache entries, entirely. So in terms of lists, we would like to invalidate them because, you know, they could reorder. One query like one item could be removed from the list, but also they can reorder. But when it comes to the details of a certain entity, it doesn't make sense to hold it anymore. So, you know, in different situations, different strategies apply, though this one seems to be, yet again, a quite sane default. But again, what you need to think of is how do you design your query keys? So you don't care about HTTP that much. You don't care about, you know, fetching, refetching, prefetching, caching, etc. You think about how to organize the resources that you load, because yeah, you have a products endpoint, but actually you can paginate it, you can sort it, you can filter it, you can ask for details. It's like, how do they relate to each other? Are they the same keys? Are they the same resources or different ones? This is what you're thinking about, because all the rest is being handled for you by the library for free, of course. Now, yeah, invalidate is marking something to be refetched, but without removing, and remove queries is essentially the hard remove. And finally, different strategies are, invalidate queries, the thing that we've seen, mark them as stale, remove, which is, hard remove. Refetch queries means refetch right here, right now. Not very often, but sometimes you might want to do it. Reset queries is reset to the initial state, to the default state for whatever your query key is. Cancel queries. So if you've got running queries, maybe for some reason you would like to stop the requests from being, live, like reaching the server. Or maybe you know that if you have a list of, let's say, 50 elements and you remove one of them and you received to 200 OK HTTP status response, and you could reload the first page, but on the other hand, you could just return 49 of these and just display the 49 objects to the user without the reload for any business or UX reasons, whatever that is. Of course, you can run the set query data, which is going to, yet again, for the query key, execute a function that injects you whatever was the current value, and you can modify it to a new value. So like you can locally update whatever was the data within the cache, right? So like having all of these, this spectrum of different possibilities, just pick your own. And this is going to be kind of plain dumb, play easy once you actually do pay attention to what are your relations between the query keys. Something that people don't think about, like without Angular query, we don't even have something like a query, right? And even further, we don't have anything like a query key. But again, we think like about a product or product list, and we replace totally different resources under the very same box, the very same variable. And here, thanks to distinguishing it, we can be way more effective and provide better experience for the user. Yeah, so think of query keys as resource identifiers, as said before. So we can think of, let's say, all products to be defined just as products, but that doesn't mean these are going to be all the products returned from the the server API. But this actually means that everything, all this is going to match all the keys that are longer than just only the first element of the key needs to be products, and whatever are the further elements are just going to match to this one. So here we've got another example, which is product filter by name. So the first element is product, and let's say that the second is the filter XYZ. So if something includes XYZ in the name, basically this would be matched. And finally, the product given by ID. So let's say products and 1, 2, 3. So that would be a product details of an entity that has an ID 1, 2, 3. So how does this matching? Before we do the matching, how could we do it slightly more explicit? So let's say that if we want to make it more readable, let's distinguish the situation where we have products list from a situation where we have product details. So product list just includes 2 elements, and as you can see, just whatever the server returns as the first 20 products, 50 products, 100 products, still, this is just the first page whatsoever. We can also make pagination very explicit. We can also provide what is the filtering by whatever criteria you want to filter by. So products, list, and name XYZ. Product filtered and paginated at the same time. And here we've got products list, page 1, name XYZ. And finally, if we don't want to have a list, but we want to have details, which, yes, this does correlate with products, but this is not a list, this is detail. This is totally different kind of query, as we have seen. The lists, after removing an element, lists were invalidated, but details were entirely removed. They serve different purposes. Hence, they not only have different keys, they have totally different groups of keys. yet again, what you see in this slide, this is basically the whole design behind query keys. So here we've got the query key pattern matching. So at the very bottom, we've got various lists of potential query keys, and at the top, we try to match. So if I just pass products, let's say for invalidating, resetting, caching, removing, setting, like locally updating, etc., then as long as you, like, all the elements match, like you could have more elements in the query key. So as long as all the elements match, like they are going to match. So products is going to match all of these. Now, if we pass products list, all the products lists are being matched. Product details are certainly not. That's the whole point. Now, if product list page 1 gets passed, then as you can see, only line number 8 gets matched. So only products list page 1, but line 9, products list page 1 XYZ is not going to be matched. Why? Because it's not that, let's say, page is more important than the name filter. No, they are of kind of same importance. So either they match both, or they don't match at all, right? Like this, this only exposes how REST APIs should work anyway. Like this is kind of natural. We just kind of formalized this. With product list, page 1 and name XYZ, obviously line number 10 is being matched. And finally, when we run product details 1, 2, 3, then yet again, we need to find all the queries that have exactly the key of these elements, or maybe some more. But if a key is identified by being a details of a certain ID, then I don't think that any further elements of the key would make sense at all. So products details 1, 2, 3 is matched. Obviously 4, 5, 6 is not. So this is going to be probably the default, let's say, design behind query keys that you would that would fit in a typical application most of the time. And by the way, what I'm describing to you is kind of based on my experience with React Query, which has been around for 5 years or 6 years, and React Query has taken the React community by storm. And Angular Query has been introduced very, very recently. It is kind of 1 year old, and it hasn't been available for long enough, so people in the Angular community don't know it yet, though the whole solution is battle tested in React community, and it's pretty much, the whole core has been extracted away to make it, React agnostic, and now there are adapters available for all the frameworks. So as you can see, this is really well thought, and yeah, thousands of applications have been using it, but not with the Angular adapter, but with the React adapter. So as you can see, there is really hundreds or even thousands of hours of hard work and design work how to make all this be convenient and so on and so forth. So yeah, like, don't think of it as a new library. Think of it as something that has matured over 6 years, but in a slightly just different JavaScript community, in React community. But now it's again framework agnostic. So yeah. So just to sum up, why bother? Because when fetching data, sooner or later, you will need to think about, if not all, then vast majority of the topics here. So there is no, need to figure this out on your own manually. If you can basically take something that is battle tested, very well designed, and yeah, use it and be happy. As I said, I cannot, like, when loading any state from the server in React applications, Vue applications, etc., the first thing to do is I find whether there is an adapter, like Tanstack query, the core library adapter for a given framework. Most often there is, like, there are 6 libraries: React, Angular, Vue, Solid, Svelte, and something more. Cannot remind what was the other one. Yeah, so this would be the thing. And thank you very much. Thank you for listening.
Thank you, Tomasz. So right now we'll be starting the QA session. So if anyone has any question, feel free to raise your hand. I will give you the mic. With a little spice on top of everything, we are going to be playing a little Secret Santa game. So anybody that asks a question that Tomasz would not be able to answer will get a 15 euro gift. Okay, any questions? 15 euros. Okay. Okay, Tomasz.
I have a question to the audience. Like, what do you think about the whole thing?
If it works, thumbs up. If it doesn't, thumbs down. Okay, thumbs up so far. Yeah, hands up, it works. I guess everyone was following and learned it from the first show, right?
Okay.
Okay, Tomasz, thank you very much.
If you have any questions, then you can see my address, ducin.dev. So yeah, feel free to reach out to me. Thank you.
Thank you. Okay, so our next speaker will be joining any moment now. His name is Julian, and he's a senior software engineer. He's working for Push-based for the last couple of years, and his focus is, as he said it, software engineering problems, where he's focusing on how to solve the problem properly, not how to move the button left or right. So Julian, go ahead, you're next. Also, guys, take notes. The same thing will apply for the Q&A for Julian. And yeah, try to figure out some nice questions.
Okay, it's already my turn?
Yes, go ahead.
Okay. Hey, Tomasz, by the way. And hey, Kirill. And hello, everyone else that is listening to me live now. Let me quickly share my screen. I will go for entire screen share and hope everything will be good in this mode. Let's go ahead and press this button. And please give me someone a sign that everything is good and you can see stuff. Not a visual sign, I need audio cue. You see my slides? Good.
You can
Perfect.
see your demo. Go ahead.
Thank you, Kirill. So first of all, hello, NG Macedonia. Thanks for the nice invitation, Kirill. If someone didn't know, Kirill and me just met in Belgium, actually, on NGBE, and he was so kind inviting me to this wonderful meetup. And this is also first anniversary, so happy birthday at this point. And by the way, this is not the correct intro slide. This is the correct intro slide. And in case you didn't know me, I'm really a performance lover, and my presentation will be a lot about performance, about the topic of it. And I hope you're as excited as I am to listen to my talk with the title, Cut My Task into Pieces. This is concurrent mode. So usually I can hear your feedback right away. Right now I can't, so I just hope you have a smile on your face right now after hearing me singing, because I cannot really sing, but this title just had to be sang. So excuse me for that. Let's go right into the topic. What happens when a user interacts with your application? Well, the browser will create a task for it in order to execute the scripts you wanted to get executed at this very moment in time. In our case that we see right here, so this is a generic task, we have a click event listener. Let's break down what we see here. So one task is any discrete piece of work that the browser does synchronously at once. So in the top row, we see the browser events. So in the thick yellow color, there are browser events. Below that, in another color, this will be the application code that you see. So the code that you have written that your application should execute, or maybe third-party extensions that users have installed. Think about password managers that also happen to get executed on that. And lastly, we see the purple and the greenish colors here, and those are rendering and painting phases, what the browser does. And we want to focus on the yellow part and the blue part, so on the scripting part. There are also long tasks. A long task is any task that takes longer than 50 milliseconds at a time. So this is something from the browser for developers indicating a warning. So anything that takes longer than 50 milliseconds should be considered as, hey, maybe you want to take a look at that, because it's kind of already getting dangerous that people get upset because your page is so blocking. So any task that exceeds this 50 milliseconds threshold is considered a long task. And you see this red shifted area here, and this is considered as the blocking time. So in our case, from this example here, the blocking time is around 15 milliseconds, as we have a task that has a duration of 64.9 milliseconds. And it looks kind of scary, doesn't it? I mean, it's red. Red is always danger color, signal color. So why should you actually care about that? Because there's this wonderful new core web vital called Interaction to Next Paint. Interaction to Next Paint indicates very clearly in a very, very good way. So I'm extremely happy that this one exists from, by the way, 2024. So this is a very new core web vital. The web vitals are a living standard. And this indicates how snappy, how responsive your application responds to user input. So it measures the time from someone interacts with your page until the next frame can be presented. Let's break it down. INP has 3 different stages. So it has, first of all, the input delay, which is also very important. Usually when the page is in full idle mode, that should be 0. This is the time the browser needs or has to wait until it can finally process a user interaction. And we will come to some examples how this can happen. Then we have the processing time. Obviously, this is the stuff that you wanted to get executed. So on a click listener, you want to change a class, you want to inject or add a DOM node, remove a DOM node. That's your scripts that are running, or compute new states. And then in the end, there's again something that the browser just does, depending on what changes you have introduced. It needs to render the stuff. And this is called the presentation delay. So if your DOM is very heavy, then you can have high presentation delay. With all of that information, let me quickly introduce myself. So hello, everyone, again. My name is Julian Jandl. I'm a software engineer, trainer, and consultant. Sometimes I'm also a speaker for the company of Pushbased. And usually what I do is I'm improving, obviously, the performance of web applications. I also do architecting with Angular, especially with NX. So this is where the scalability part also comes in. I got recently certified NX expert. And yeah, this is what I currently do, and this is who I am. So let's dive into our first live demonstration to demonstrate how long tasks and INP are working together. And for this, let's just start with the demo application. So this is where I can introduce you to my wonderful demo app. And as you can see here, I have the DevTools here open on the right side. I have the application here open on the left side. And right now, everything is just in blank mode. So blank, nothing is here, no DOM node. So let's do something funny. Let's throttle the CPU for a bit, because usually developers have strong machines and maybe you don't even notice that the performance is not so good. In that case, I really highly recommend to try out your page with a throttled CPU and see how it behaves then. And as you can see here, I see interaction to next paint directly embedded here in the performance panel as part of the new local metrics feature. So what I just want to do is now do a normal native navigation synchronously. So I will just click this button here and navigate to a page. And et voila, we have an INP of 1.5 seconds. So that means my browser was now locked in for 1.5 seconds just to render this new page. Let's do a measurement of that. So I will just do a recording now. press this button, and then I stop the recording. And now we can see here in the flame charts, I hope this is huge enough. Maybe let me even make it a little bit larger, close down the summary. And here we have now the flame chart presentation. So it should look kind of similar, closing the frames as well. So this should be now straight to the point. Kind of similar as I've shown you before in the overview slides. So this is how the flame charts are presented. We see our click listener here, event click. We see here in the interaction track also, it tells us there's a very long interaction happening, right? So pointer event is very long. And you see also how the DevTools break down into those 3 stages. Input delay is very little, 6 milliseconds. Processing duration is extremely high, 1.2 seconds. And then presentation delay, only 44 milliseconds. And you can see here already something that is going on. So we render kind of the header, we render the sidebar, we render the content, and we render the footer, plus something that is going on here. Let's take a look. So this looks like list items, so a lot of items. This looks like an iteration of multiple pieces that are kind of the same. And I can just tell you right now, this is rendering all of those list items here. So of course, I've artificially put a lot of work here into those components to make them really slow so that I have an easier time explaining that, but this is how it looks at the moment. So let's go back to the blank page for the next demo section and go back to where we started off. So this is how long a long task looks like, and this is how INP is derived from it, and how INP is immediately affected when you have long tasks directly on a click event listener. What I forgot to mention is INP is a very relentless metric. So the worst interaction that happens on your page will be the metric that Core Web Vitals measure. You can have 100 good interactions and one really bad, and the one really bad will be your INP value. So this is how relentless it is. So what options do we have in order to fix this scenario? We can be just super smart and say, we schedule that thing. How can we schedule work into the future? There are several APIs that we have available just from the browser, from the JavaScript ecosystem. And first of all, this is the timer API. So set timeout, set interval. Then we have request idle callback. We also have the post task scheduler, which is something very new and only working in Chromium-based browsers. And then finally, we have the message channel, which is typically only used for cross-tab communication, but you can also use it as a set timeout. So let's take a look again. Our example yielded a lot of, or showed a lot of processing time. So how can we fix that? Well, we just say we detach this work, this huge task, from the click listener itself and schedule it into the future. And this way we kind of hack the metric, right? Let's take a look at if this is actually working and doing what we want. So first, let me quickly show you how I did that. This is the code of the app component that I've shown you before. So you see here this navigation bar going on. Here you see the button with native, which just uses a native router link. You should be aware of that. And here is the scheduled route. So in the scheduled route, you see we have a click event listener, and we say navigate to native scheduled. And here it says use a set timeout to schedule the navigation event into the future. So this is how it's very naively implemented at the moment. So let's go ahead and check out if this is helping at all. I will just clean my DevTools, do a quick refresh here so that everything is in a fresh state. Interaction to next pane is now nothing. So what I want to do again now is throttle my CPU again and then click on scheduled. And there you go. INP is now 40 milliseconds. So before we had around 1.5 seconds, and now it's only 40 milliseconds. Well, what should we say? Yes, it works. But there's always but. Schedule a long task for better, like really better in quotes, better INP, kind of has a drawback, a really huge drawback to it. So if you do kind of that stuff, you must be aware that you have still a really huge blocking task on your main thread. And since JavaScript is single-threaded, which we will discover also during this talk, the browser is kind of blocked in a moment where the user could potentially again interact with your page. So just imagine the situation that your user again tries to interact with the page here while this blocking task is going on. And what then happens is you have high total blocking time, and a result of that most probably is you have high input delay for subsequent interactions. So this is how high input delay can happen. Why is that the case, you might ask? Because JavaScript is super single-threaded. I already mentioned that. Let's discuss the event loop that is kind of the whole reason behind that. So the event loop is an ever-going while loop built into the JavaScript ecosystem, into the JavaScript runtime. It kind of waits for a message, a new task to execute, and when there's a new task, it executes it. And if it's done with that, it can pick up the next task. If you're wondering what is this queue, the queue is the so-called macro task queue. So what causes a macro task, you might ask, or you might wonder? First of all of the scheduling techniques. So set timeout, request idle callback, request animation frame, the message channel, and most importantly, each and every DOM API or browser API that you can think of. For example, window resize, mouse down, mouse click, mouse up, hover, blur, focus. All of those events will spawn a new macro task into the queue and then get executed one after another. There's nothing that can get parallelized at all. So yeah, the macro task queue has to follow the run to completion model. That's the so-called model that stands behind it that makes it single-threaded. So this is how it would look like when you kind of try to visualize or compare event loop plus how it's visualized in the flames. So in the left example, we have a script evaluation, then mouse down, that's the event we are currently at. In mouse down, we have two functions that needs to get executed, work and work2. And now you can see already code that we read from top to bottom. So work is standing atop of work2. In the flame charts, they are visualized kind of in a different way. They are visualized next to each other. And this is indicating the time they take to get executed. So work is getting executed first. When work is done, work2 can get executed, single-threaded. Now, after work2 is done, the macro task can be completed and we can go on to event click listener. So in event click, we do something on click, quite obviously. So this function has to complete until we can come to the timer fired. And now we switch a little bit our perspective and have them horizontally aligned. And in the end, we have timer fired, which maybe is a long task because we are smart and want to improve our INP by using scheduling techniques. But the user wants to, again, interact with your page right when our big long task is getting executed. And when that happens, the browser already knows it has to execute a click listener again. But it cannot do it at this point in time because it's busy executing whatever callback is happening in the timer fired. And this is causing, in the end, high input delay. So this is kind of the reason why high total blocking time kind of can lead to high INP. Not kind of, high total blocking time can lead to high INP. So what do we do with the long tasks then? Well, my good friend Kirill suggested to just play bricks with flame charts. This might look like a fun job, and if this was would be reality, I would be the best player in the world in this game. But sadly, this is just joking around. So let's talk about the actual serious stuff that we can do. Of course, always the preferred solution should be reducing work. So just do less than you did before, right? Optimize your code, do less iterations, render less items on the page, stuff like that. It's of course preferred, but not always applicable. Sometimes everything is already optimized from your end, and you cannot do any more. So what can you do then? You can distribute the work. So try to chunk your big work into smaller pieces and execute them bit by bit by bit. Where do you distribute? Of course, on the main thread. And then finally, if you have distributed your work, you want to also prioritize it, because most of the time there's something that is more urgent than other stuff. Think about storing stuff into local storage, sending a beacon to Facebook Messenger or to Facebook tracking services or Google Analytics or stuff like that. This is less important than doing the actual stuff important for getting the next frame presented for your user. And now, let me introduce you the concurrent mode, which we've built for Angular itself. The concurrent mode has a conceptual overview, which I want to explain to you. So it's built around those two major steps, distribution and prioritization. For this, we need to know concepts around scheduling. We are already aware about that. Chunking, that's the new stuff. A frame budget, which I will also explain later. And finally, sounds very easy, is harder to implement, prioritization. So scheduling, we know that already, right? Installing a set timeout, for example, executing stuff in the future. Chunking, this is now getting interesting. So we have something that is quite huge that we want to chunk down in, let's say, 3 equal pieces and then execute them bit by bit in order to get the ability that the browser can, first of all, paint in between, second of all, can react again to user input, which might be more urgent. Think about someone changing a filter from one to the other, and your list is responding to that. Would be nice if you can just constantly switch filters without being blocked in between, right? So again, we have the example from the demo app before. You have a header, a sidebar, a body, and a footer. So in the flame charts, that's what we also have explored before. It looks kind of like this. You have a click listener, then a header, a sidebar, a body, and then a footer component getting executed synchronously, immediately on click, everything at once. And the user has to wait until everything is finished, and then you get the next paint. So we want to apply chunking, of course, in order to separate, let's say, on component level, in this case. So separate the header from the sidebar, from the body, and from the footer. Chunk them all together. There are several options here. We here in our Angular universe, we might want to focus on the topmost example here. So for Angular, there are directives. First of all, the rxlet directive. And to render lists, there are also other directives, for example, ng4. But you can also do this in React. This is where the idea originally comes from. React implemented this just into the framework. It's an experimental feature, but still, it's part of the React core. So there you can use, instead of use state, just use transition and achieve something similar. Or you can use our implementation from Rx Angular, use the scheduler, and, for example, build yourself around in lit HTML. This is also working. So yeah, we want to be able to slice our work on the template level. And of course, not only on different single templates, single component, but also on list items, because list rendering in a lot of applications, especially on those internal ones with big tables, is heavy work for the browser. Just think about, you want to render 500 list items, and each and every of them comes with their own buttons and menus and reactive titles and, I don't know, edit buttons and stuff like that. that can get quite horrible for the browser to render at once. Of course, on your new MacBook Pro, you might not notice, but something that is joining with a thin client will notice for sure. So the idea is, of course, here as well, chunk the lists by kind of the item and render them bit by bit by bit. Lastly, we also have a so-called frame budget. So frame budget means you control how big those chunks are. By default, it should be configured to around 60 FPS. So the algorithm behind the scenes should try to make your tasks last as long as around 16 milliseconds. That's the maximum it should strive for. Of course, it's not perfect and it cannot be perfectly fitted, but that's the goal it's trying to achieve. And by increasing the FPS, you decrease the size of the chunks, or by decreasing FPS, you increase the size of the chunks, of course. So how is this measured? Let's take the example with 60 FPS. You get one piece of work and the algorithm counts how long it takes to execute it. And in this case, it took around, let's say, 4 milliseconds. So we know it fits the threshold. So next one, still fitting the threshold, right? Next one, still fitting the threshold. So let's give me yet another one. And now we have exceeded the threshold by a tiny bit. And now the algorithm says, okay, it's time for a new fresh paint. So let's stop right here and schedule everything else that's left in the queue for future, giving the browser again control to react to user input and stuff like that. So again, we have an eternally going on while loop built into the concurrent mode. So as long as there are tasks and our runtime is smaller than the threshold we have configured, take the next task, execute it, and measure how long it took. That's as simple as that. Let's take a look at a live demo about this. So we are back in our wonderful demo application, and I want to refresh now once. I still have CPU throttling enabled at the moment, so 4 times slowdown. And let's go now to the concurrent rendering. Before I do that, let me quickly showcase the problem with high total blocking time and high INP. So what I want to do now is navigate back and forth between blank and scheduled. So this is what I'm trying to achieve now. Navigate back and forth between blank and scheduled. And now you can just tell here by the interactions pane here. Let's zoom in a bit so that we see, you don't see more, just is hidden away. Maybe this is better. So you see a lot of interactions that take ages here, even though we have applied the scheduling before, right? So we made sure already that scheduling is applied, but still there are happening interactions in between. And I can also measure that. Let's quickly do that as well. So starting the measurement, clicking on scheduled, and then in the middle of that, I'm trying to navigate back to blank page. Yes, and this is exactly what's happening then. So we have a wonderful first INP value here. This is our first INP, 28 milliseconds, super nice, nothing to complain about. Then our big timer event that we have just scheduled into the future kicks in. And in the middle of it, exactly at this point where the candle starts, we see I tried to interact again with the page, but it couldn't react because, well, there is a long task already executing at this point in time. So this is how you can see here now, also in the breakdown, it says input delay 1188 milliseconds. So now we have super high input delay, very little processing duration. So that was the example from before. And now let's talk about how concurrent mode helps here. So again, I'm at the blank page and now I go to concurrent. And you can see here already, I can navigate back and forth and back and forth and back and forth, like without that is any issue whatsoever. I still have throttling enabled, so I don't trick you here. And you can also see how those components are like bit by bit entering the scene. Let's quickly do a measurement of that. So I'm clicking on concurrent now. There you go. All the items are rendered. And this is how we see now, what we see now. So now this 2-second super long task is now split down into 4 pieces by template: header, sidebar, content, and footer. Header, sidebar, content, and footer. Let's quickly take a look at the code, because I told you that we can improve list rendering as well. So I go to concurrent component now. And as you can see here, I have applied just to each and every component the rx-let directive with an empty input to create one chunk each for the header, for the sidebar, for the main content, and for the footer. And now what I can do is replace ng4 with rx4. Let's check again what's happening. I navigate away, clean everything, maybe do a quick refresh, start another measurement, go to the concurrent page now, and now you see, maybe you could visually tell how the bar here, the scroll bar, shrink and shrink and shrink and shrink until it's the current size. And we can see here also in the flame charts, if we compare what we had before, the rendering the body was about a second or something, and now the body is kind of tiny, and instead here in the end, what we see here, all the chunks, we can also tell visually by hovering here, entering slowly into the scene. So this is the list rendering going on, and here we see, for example, list item work, list item work, list item work happening, just scheduled across the whole process here. And yes, in total, we spent more time in rendering. This is not 2 seconds and not 1.5 seconds blocking time that we had before. But the browser has constantly windows where it can react again to user input. And this is the whole story around it, how it improves user interactivity. Okay, so this is how we ended up right now. We have header, sidebar, body, and then footer rendered. So you might remember that I was talking about priorities as well. This might not be the end result you actually wanted to have. So maybe you want to have body rendered first before the header, because body is the most crucial information for you. And then sidebar, and then header, and then the footer. So you want to switch priorities around, even though your template is defined already in some form. So for this, there are also priorities which you can apply. And priorities kind of, they have a little bit more of a concept than just being a number. That's why they have a name. But diving into all of the concepts would blow the talk a bit. So let's think about them as numbers. We have immediate as our highest priority. We have user blocking as priority number 1. Normal, that's just the regular default priority. Then we have also the low priority, and finally the idle priority for stuff that is super not important and can be idle forever. So let's take a look at the prioritized example. I told you about strategies and inputs. So the rx-let directive and also the rx4 directive are able to receive the priority by their name. So the name for the input would be strategy, and then you give the name of the priority, so low and immediate, to the respective piece that you wanted to prioritize different than normal. So we say rx-let directive for the header bar should have strategy low, because header is not important for us. Sidebar, just normal. The main content, though, is important for us, so we say main content has immediate strategy. The footer strategy is, in this case, low. And for all the list items, we have, in this case, user blocking strategy. So let's take a look at the final outcome here and create yet another measurement for the concurrent prioritized mode. And you could already visually tell that now we start with rendering the body and all these items. And when the items are ready, we kick in with the sidebar, the header, and the footer. Please don't consider this as a visual glitch. It's not glitching at all. This is expected behavior. And of course, it's extreme in this demo application because I wanted it to be extreme. It's even taking ages if I do not throttle the CPU. That's because of the code that I put in there. It's artificially bloated. But let me quickly show you one cool feature here in this demo application before I wrap things up. So now I can go ahead and just navigate between concurrent mode and concurrent prioritized. And during whatever step that's going on, I can immediately, you can tell, I can immediately abort what's going on and move on to the next paint. Let's try that again between native and scheduled. I already clicked. Now it rendered. And now let's take a look at the live metrics again. 3 seconds of blocking time because I bloated the main thread with so much work. And this is where concurrent mode really comes into play. Fast navigations from users. Abort stuff that is already in progress. And now let me give as a final example. Unthrottle the CPU, maybe that's a good idea. Go away from this mode because I want to show you one live application that we as a team improved. Let's do a 200% zoom. I guess this is fine. Yes, perfect. So this is a page that you might know. So it's a sports betting page where we also introduce this concurrent mode in order to, for example, make navigations like this here. And you can see now faster. So this is nothing that is only experimental or you should just try in your pet project. This is active on applications that have several million visitors a day. And we if you do it right, you do not suffer from layout shifts and you do not suffer from any visual instability. Instead, you improve the interaction, your interactivity and responsiveness of your application a lot, especially for those users which have slow devices. And with that being said, again, I want to emphasize RX Angular concurrent mode. So if you are interested in trying that out, go to our GitHub channel or go to our GitHub page. Leave a star there, of course, very important. Download the package, install it, try it out, and give us feedback. If in case there's anything missing, raise an issue. We are happy to answer and help you out. I also want to emphasize or give a shout out to my good friend Kirill again, who wrote a absolute masterpiece as a blog post, Mastering Interaction to Next Paint with RX Angular. Check it out. It's on the push-based homepage. And with that, I just have to say thank you for your time. Thanks for listening. In case there's anything you want to know, just ping me. Here's a QR code. I will just leave it here for, let's say, 5 seconds. You can just check out the slides. And I think the repository link as well. Otherwise, I will just leave Kirill with the link and also the link to the repository, and here he can share it on site with you on the meetup. Final word, our wonderful company Pushbase is doing web performance consulting. So in case you need something like that, just leave me a message. And with that, I can stop the presentation.
Okay, Julian. Thank you very much. Any questions? Come on, guys, I would have found something hard by now. Okay?
Hi. I have a question regarding which tools are the best for measuring the ENP for our website, for our web application?
Tools, what are the best tools to measure ENP?
Yeah.
I would say just the performance panel is super fine at the moment. Let me quickly share my screen. There are some browser extensions that you can use. Entire screen. So there is a what is it called? Core Web, no, just Web Vitals extension. Yes, Web Vitals. You can install it. It's a Chrome extension. And you can configure it to print out console logs. So then you can go to console and filter for vitals. And if I now navigate here, you see all those logs here. So for example, for this interaction, it will just log it out. Tell me which item was involved here and how high was the timing and also the breakdown. You see it here in the console. So this is quite helpful. In case if you want to see what real users are experiencing on your page, then I would rather go to the Crux dashboard, which is like as long as your application is indexable, you can just go here for free. There's no registration needed. Let me do that for bwin. Just enter your URL in the Crux dashboard, and it will give you like real user measurements, like how your users actually feel your page. And if you're interested in INP, you just click on Interaction to Next Paint, and it can break it down for you historically and divide it into good interactions to be improved and poor interact 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 and